Hi Star. Here's a quick video on y equals sine x. I'll send you another one tomorrow on cosine x. If you decide you don't want the cosine one, that you think you have it down with sine, because they're both very similar. They just look slightly different. Let me know. If not, it doesn't take long, a few minutes to make one of these. But anyways, here's your sine graph. Now this is a trig graph because sine and cosine are trig functions. So when you graph it, there's no change in your y-axis. It's still going to go 1, 2, 3, 4 up, negative 1, 2, 3, 4 down. But the x-axis is graphed in either degrees, 90, 180, 270, 360, or in radians. Now previously, in the previous trig chapters, they should have told you how to convert from degrees to radians. Radians just measures the arc in a circle in units. These are measured in like centimeters, like this would be 3.14 centimeters, where degrees don't change as the circle gets bigger. But you should know that 90 degrees and pi over 2 radians are the same. 180 is pi radians. 180 degrees is halfway around a circle. All the way around the circle is 2 pi. So 2 pi radians tells you the circumference of a whole circle. Pi is a half a circle, and 90 degrees is a fourth of that. So you cut this in half, and that's where the radians comes from. That's a different unit. And if you're going to graph, you're going to go to zoom, and if you want the calculator to know that it needs to put degrees here and not 1, 2, 3, make sure if you want to graph these in your calculator, you go to zoom and you put your calculator in trig. So do that, and then I'm going to set it aside and we'll worry about that later. Now, if you'll notice, the sine curve always looks like this. I refer to it as a hill and a valley. It goes up and it comes down. The length of the hill and the length of the valley are exactly the same. So it'll go up, come back down, go back up. And then it does that again. We usually stop it at 360 because that's the whole curve. But if it keeps going, it's going to go up and down, up and down, up and down. That's all the sine curve does forever. It could go this way and it would go down and up, down and up. It never has 2 hills in a row. It never has 2 valleys in a row. So it goes up and down, up and down, up and down. Now, if you go to your calculator, notice these are degrees. If I put my calculator, this is the mode button. If I have it in degrees, now if I clear that, and I put in sine of 90, it'll tell me sine of 90. Yep, that's 1, because at 90 degrees, that's the highest the sine graph is ever going to go. Sine of 180 should say, where'd the sine button go? Sine 180 is 0, because after it goes up, it comes back down. And I'm just going to hit second enter. Nope, I didn't do that. Second enter, and I can change this to 270. Now it already went up. It went up at 90, came down to 180, so at 270 it comes back down, and then it goes back up at 360. So that's a sine curve. And that's how you can, some of these you can find in the calculator. Now if you put in sine of 80 degrees, it's going to give you a big, long, ugly decimal, because these are bad decimals. You'll get a half in here someplace, because if you remember your special right triangles, sine of 30 is 1/2. So some of them will look nice, but the vast majority of these will look like long, ugly decimals. Now when you have to graph it, besides sine x, the sine tells you go up, go down, go up, go down, hill, valley, hill, valley. Now there's 3 things, there's really 4, but we're only going to talk about 3 of them. There's the 3 general things you can do to a calculator or to a sine graph or a trig graph is the amplitude, that's A, and that measures the height from the middle of the graph, wherever the middle is. How far up does it go from where it starts? And that measures height. But remember, it's not height from the top to the bottom. Now, right here, I'm just looking at your normal graph. This is your normal graph. There's 2 of them here. But if you look at the pencil graph, it goes up 3, comes back down, goes down 3. That's y equals 3 sine x. That's your amplitude or your height. Still has the hill, still has the valley. Now the blue graph does the same thing, but it goes down first and then goes up. It's upside down. If your sine graph that is supposed to go up and then down goes down and then up, there's a negative sign there. So that's y equals negative 3 sine x. But what's really important to remember is both these graphs, the pencil and the pen, both have an amplitude of 3. Amplitude cannot be negative. And they often say that the amplitude is the absolute value A because it measures distance. This distance is 3, this distance is 3. So the amplitude is 3. That negative sign just tells you go down and then go up as you start your graph. Now the next letter is B, and B is the frequency. That's the number that comes. The amplitude is before the sign, the frequency is after the sign. And the frequency tells you how many graphs you're going to have in 2 pi or 360 degrees. Because the vast majority of trig graphs are in radians, I'm not going to list the 90, 180, 270, 360 anymore because most of them want you to graph in radians. So I will put up here in 360 degrees or 2 pi radians. Now normally you're supposed to have one graph in 200 and 360 degrees or one graph in 2 pi. One hill, one valley. That's a frequency of 1. Now this pencil one goes up, goes down, and there's one graph. There's a sine graph. Then it starts again, and you have 2 sine graphs. So from 0 to 2 pi, you have 2 sine graphs, and that's a frequency of 2. The blue graph stretched it out, started at 0, at pi, it went down and then went up. This just has the valley. There's no hill, there's just one valley. You can also count up here for this frequency. You can count, there's 2 hills, that's a frequency of 2. Make sure though that each hill has a valley. This one just has a valley. Now the sine curve is supposed to go up first. This one went down. So that's why that negative sign is there. That negative sign says it's upside down. And from 0 to 2 pi, I only have half a graph. And that's why the frequency is 1/2. So that's what this number is, the frequency. Amplitude comes first, frequency comes second. And then the last number you have is a D. There is a C in here, but we didn't deal with C. You can deal with that. We usually do if we were in class, but we didn't have time. And they'll deal with that in pre-calc. If you get, and I would strongly encourage you to take that because in pre-calc, they'll go over all the pieces that we missed in Algebra 2, and there's no Regents exam, and they can go at a slower pace. It's really a nice course. So D is the midline or vertical shift. It's called both of these. Now, once again, here's your normal, ordinary, run-of-the-mill sine curve. It's going up, it's going down. This has a frequency of 1, because I only see one graph. And it goes, whoops, I gotta check this. I'm gonna squeeze this in. It does, however, though, have an amplitude of 2, because from where it starts, it goes up 2, it goes down 2. So I put a 2 in there. It's a positive 2 because it's going up. It's supposed to be hill valley. Now, it has a midline or a vertical shift of 1. The sine graph should always start at 0. Sine starts at 0, goes up, and then goes down. Goes up, goes down. It starts at 0, it ends at 0. This graph didn't start at 0. It was shifted 1 unit down. That's a vertical shift down. Now they call it midline because these 3, in a sine graph, there's always 3 points that are along the middle. There's the middle, goes up, back to middle, down, back to middle. This is your midline. So if you draw a line, and I drew a little squiggly blue line, through the middle of your graph, that will tell you 2 things. From that little squiggly line up to the top gives you the amplitude. From that squiggly line, if that's not at 0, it'll tell you if you went down, it's a vertical shift down. If it went up, it'll be a vertical shift up. So that is your D, or vertical shift. A, B, D is all you need to know about graphing a sine graph. Now, the last thing they talk about is period. Period is the length of time it takes. How many degrees or how many radians does it take to complete a graph? And there's a formula for it. The formula for period is 2 pi over b. And of course, 2 pi radians is 360 degrees, so both formulas work, and you can tell looking at the question. If it has a pi in it, you're using this formula. If it gives you degrees, a big number, you use this formula. Now here are 1, 2, 3, and I'll number them. Here's 3 examples. Here's 1 graph, here's 2 graphs, here's 3. This one has a, remember, amplitude, frequency. This has a frequency of 2. So this is 2 pi over 2, 1 over, these 2's divide out. So this period is pi, or 180 degrees. And that should make sense because this has a frequency of 2. So it's going to take 2 graphs to get to 360. If I go back, remember the period, I'm trying to go back here, I'm getting it, the period is, where's the period? Or the frequency is how many graphs in 360 degrees, or 2 pi radians. So this is supposed to have a frequency of 2. So there's 2 graphs in 360 degrees, which means the first graph is going to have to finish it in 180. So we have another 180 degrees to get to the second graph. So that's that 2. This is how long it's going to take to finish. And if I go back here one more time, see this had a frequency of 2. It finished the first graph at pi, and then it finished the second graph there. Now, if it has a frequency of 3, and I messed this up first, that's 2 pi, it's always 2 pi over b. This time the b is 3. So this is going to take 2/3. Don't look at that. Now, now remember pi radians is 180 degrees. So 2 times 180 divided by 3 is 120 degrees. So because this has a frequency of 3, one graph will be in the first 120, and then 2 graphs I'll be at 240 degrees, because that's 2 120s, and then at 3 graphs, hooray, hooray, I'll be at 360. So anything that has a frequency of 3 will have a period of 120 degrees, or 2 pi over 3 radians. And then finally, I did 5 sine x over 2. Now, sometimes it says x over 2, sometimes it says 1/2 x. But this frequency is 1/2. So that's 2 pi over 1/2. You're dividing. So that's 2 pi divided by 1/2, which means you multiply by 2, which is 4 pi. Every pi is 180, so that's 720 degrees. And that, again, should make sense, because if you look back here, where is it? Here's 1/2 x. It took 2 pi's to get half the graph. So if you want to graph the rest of it, you're going to need 2 more pi's, which is, ta-da, 4 pi to get the whole graph. Okay, now hopefully that made graphing sine curve a little bit better. Hopefully you could hear it. I've been posting every week stuff for my stats class, and nobody's ever said they couldn't hear it or it was clear. So let me know. If this helped, I'll give you another one tomorrow. If it didn't help, give me an idea what you're confused on or what I can do. So good to hear from you, Star. I do miss you. Hopefully you're staying safe and you had you had some time to enjoy this nice Memorial Day weekend. Take care, and I'll post something tomorrow if you'd like. Take care.